is a quick recording of some of the problems in electromagnetic waves. First one talks about a 2.8 ampere current flowing in the wires connected to a pedal plate capacitor. What's the rate at which electric field is changing between the plates if the square plates are 1.60 centimeter on a side? Displacement current is given by this equation. ID displacement current is epsilon naught A dE by dt, where that is the rate at which the electric field is changing. So you're asked to find dE by dt, and the displacement current is given. So make dE by dt the subject and calculate. You will get it as 1.2 times 10 to the 15 volt per meter second. In the second one, who will hear the voice of a singer first? Person in the balcony 50 meters away from the stage, or a person 3,000 kilometers away at home whose ear is next to the radio? And how much sooner? Assume that the microphone is a few centimeters from the singer and the temperature is 20 degrees Celsius. What you got to understand is that the person in the balcony hears a sound as sound travels to him, and so it travels at the speed of sound. But the person who is 3,000 kilometers away, he's listening to his radio, so it's electromagnetic waves that reach him, and they move considerably faster. Now, you got to first find the speed of sound at 20 degrees Celsius using this equation, where T is the temperature, which is 20 degrees Celsius, and then from that, time is distance by speed, so you get 0.146 seconds. On the other hand, for electromagnetic waves, that's in meters now. 3,000, that's 3,000 times, no, it has to be 10 to the 3, okay. So that's in meters now. So distance in meters divided by the speed of electromagnetic waves, which is 3 times 10 to the 8, so it only takes 0.01 seconds to reach the person 3,000 kilometers away. Number 3, the magnetic field in a traveling electromagnetic wave has root mean square strength of 22.5 nanotesla. How long does it take to deliver 335 joules of energy to 1 centimeter square of a wall that it hits perpendicularly? Okay, that's a lot of energy, 335 joules, and this is where we use the Poynting vector, which is defined as the energy per unit area per second. So it's the total energy by the area by time. And it's given by CB squared RMS by mu naught. C is the speed of electromagnetic waves. That's the RMS value of magnetic field, square of it actually, by mu naught. That equation can be rearranged to make time the subject, and all quantities are given. Mu naught is 4 pi times 10 to the minus 7, and the energy here is 335. Area is in meters squared, that's why it's 10 to the negative 4. And nanotesla is 10 to the negative 9. Okay, so when you calculate that, you get 2.77 times 10 to the 7 seconds, which is about 321 days. Number 4, a spherically spreading electromagnetic wave comes from a 1500 watt source. At a distance of 5 meters, what is the average intensity and what is the RMS value of the electric field? Remember, this question is asking you to calculate the average intensity. And the pointing vector actually gives you the average intensity. So, and it's just power over area. That's what intensity is. And because it's spreading in the form of a sphere, the surface area is 4 pi r squared. That's why you have 4 pi times the radius squared, and so you get the average. And after that, we can use this equation to calculate the RMS value of the electric field. Rearrange that equation and you would get S bar by C epsilon naught, square root of that. And I've now put in the exact numbers because when I calculated, actually I got 4.775. So that's what you see there. And it comes out to be 42 volt per meter. A certain FM radio tuning circuit has a fixed capacitor, 520 picofarad. Tuning is done by a variable inductance. And what range of values must the inductance have to tune stations from 88 megahertz to 108 megahertz? That's actually the frequency of the FM band on the radio. And so now the question is, what are the values of the inductance, And so we know that in an oscillator frequency, the resonant frequency F is 1 by 2 pi square root LC. Rearrange to make L the subject and in the inductance, in fact, and you get this. And in this equation, just substitute the value of, or in fact, the values of the frequencies, one after the other. So first time it's 88 megahertz, which is 88 times 10 to the 6. Square that, and then frequency is, the capacitance is 520 picofarads, that's 10 to the negative 12. And you get 6.29 times 10 to the negative 9 Henry. In the second case, the same equation and do the same exact thing, but this time substitute the higher end of the frequency, which is 108 megahertz. And when you do that, you will get 4.17 times 10 to the negative 9 Henry. That means, that means the value of the inductance should lie between 4.17 nanohenry and 6.29 nanohenry. And in this next question, a satellite beams microwave radiation with the power of 12 kilowatts towards the Earth's surface, 550 kilometers away. When the beam strikes the Earth, its circular diameter is about 1500 meters. Find the RMS electric field strength of the beam. In this case, you do not require the distance. You only need the circular diameter there. And the formula is C epsilon naught E squared RMS, which we have used before. When you rearrange that, you get E RMS as square root of P by A C epsilon naught. The power is 12 kilowatts, which is 1.2 times 10 to the 4. The area is pi r squared because it's a circle. And you got to take half of this to get the radius. That's why it's 750. the speed of electromagnetic waves, and epsilon naught. And the answer is 1.6 volt per meter. In the seventh one, it's a laser 15.8 milliwatt, and the beam has a diameter 2 millimeters. What are the RMS values of E and B? Again, the same formula to find the RMS value as in the last problem. Milliwatts is 15.8 times 10 to the negative 3, which is 0.0158. Again, it's a circular, so you take 1 millimeter is the radius, and that's why you have 10 to the negative 3 in meters. And then the speed of electromagnetic waves and epsilon naught. 1380 volt per meter. And after you get that, you can use this BRMS as ERMS by C. Oh, that was 1376.3. Let me use the exact number, and then you get 4.59 times 10 to the negative 6 Tesla. Brings us to the end, and thank you. I hope you could understand this.